Hi. So today is our second episode on learning PyTorch. So from zero, okay, for the beginners. Okay, so today we're going to talk about some very fundamental operations, some single tensor. Okay, so previously you can have a quick review. On the last episode we talked about the dimensions, the shape, and also the a useful function for the random number generator. Right? Or you can just use the zero function to generate a lot of zeros, right, instead of random numbers, to have some fun on those functions. Okay, so that was the previous episode. So today let's talk about some simple operations on the single tensors. Okay, such as the squeeze, the view. Okay, so the view is going to be something that we need to reshape the tensor. Okay, and later we'll talk about the function reshape. Okay, so those two are very similar, but we're gonna talk about this view first. Okay, this is much simpler. So view, and that's something for changing the shape. And we're gonna talk about the squeeze. So that is for us to zip or to reduce the tedious dimensions that we do not need. Okay, and of course we have squeeze, so we have unsqueeze. So that's something that we need for expanding the dimensions. Okay. And also the path, and we can see for example, when we write some architectures for CNN, right, for the convolutionary neural networks, we're gonna sometimes we want to pad some tensors. So this is the pad that we're gonna need here, and also we're gonna talk about this permute. Okay, so this permute, that'll be a function for us to alter or to exchange the dimensions. Okay, inside of a tensor. Good. Okay, so that's enough for the introduction. Okay, so let's go ahead and have a look at this view first. Okay, so let's have a quick note. So view is basically to reshape. Okay, tensors, a tensor. Okay, so all of those things we're gonna talk about today is just based on some specific one tensor. Okay, so later we're gonna also talk about the operations between multiple tensors, but that'll be something later, maybe next episode. Okay, so view, that'll be just a function. Okay, pretty easy to shape a tensor. Okay, so let's have a quick look on some example. Okay, so let's say some A, okay, is a torch random number. Okay, all right, so let's gonna just use this rand, okay, from a uniform distribution. So we're gonna have some shapes or some size for those dimensions. Okay, so maybe let's have maybe 4 and 2. Okay, and let's have a look on this A. Okay, good. So this is what this A looks like, right? So it has 3 dimensions. Okay, and in each of those dimensions, those are the sizes of each dimensions, right? So remember that how we're gonna count the dimensions, right? So we have those 3. So we have 3 numbers here. So we have a dimension of 3, or you can count the number of those brackets, right? Okay, so this is for the most outside one, right? Remember, so this will be the one for this most outside one. So that's going to be starting from here, actually, right? So we have 4 of those. Okay, this is 1, and this is 2 and 3 and 4, right? So that's the meaning of this 4. Okay, and inside of each one of those, we're gonna also have 4. So this is the 1, this is the second, the third, and fourth for the first one of that previous dimension, right? And similar for the others. And inside of each of those, we're gonna have 2 numbers. Okay, so this is the meaning of this two. Okay, good. So that is our A. Okay, good. So we can have a look on this shape, right? So that should be the same as our input here, right? Good. All right. So next we're gonna try this function view. Okay. So this A, let's simply view this. Okay. So it means that we're gonna change a view of this. Okay. So it's gonna change. It simply changes the view of this output. Okay. So later we're gonna talk about those the memories of those, but we just skip that for now. Okay. So this, let's say, okay. So we wanna so overall we have to still, you know, to keep all those elements. Okay, you're gonna change the dimensions, you're gonna change the shape, but you still have to keep all those numbers, right? So that's the key idea. So it means that we have to, you know, how many elements we have here, that'll be simply the product, the multiplication of those 3 numbers, right? So we have 4 by 4 by 2, that'll be this is 16, and by 2 that'll be 32, right? So we have 32 of those numbers here. Okay, so here you can't change this shape to anything that you want, but you have to make this the product of those numbers here to be 32 as before, as the same as before. Okay, so that's the thing. Okay, so let's say we're gonna have maybe 2 and 16. Okay, maybe you can have 32 and 1, or maybe like 4 and 8, right? It doesn't matter. Okay, let's have this, and let's print this in. Okay. All right. So you can see that this is reshaped, and that's actually that this is viewed, right? Viewed as this new shape. So we have 2, right, for the most outside bracket. We have 2 of those, and inside of each bracket we have 16 of those, right? And you can see that those numbers, we didn't change any numbers, right? Those 0.035, and this is here, right? And yeah, we have all those numbers here, right? Okay, good. And this is 0.3483, and that's something here, right? So we simply put all of those here and the rest to here, right? So that's how we reshape, or how we view this tensor. Okay, good. So that's one way of doing that, and maybe you could try some other way. Let's say we put 8 here. Okay, if maybe you just want you just you know you're only concerned about the first dimension here. Okay, you do not care about what else we're gonna have here. Okay, so you can put a -1 here. Okay, so it means that this function will automatically give you, it will help you just to compute the rest of it. It doesn't, you don't have to, you know, care about that. Okay, so that'll be pretty helpful. So let's print this again and have a look. Okay, so, and that gives us this, it actually doesn't, okay, so maybe we should simply erase all those. Okay, all right, so now we have all of those, right? And it helps us to to compute that, we should have 4 inside of this, okay, for each. Good. All right, so but you cannot ask that, what if we put like something may cause some error, right? Maybe we put something like 3, right? Yeah, so maybe we may cause some error, right? So let's see. And yes, indeed, right? So there's gonna be a runtime error, and this is invalid for the output side of the tree, right? So this is pretty smart, right? Okay, good. All right, so that's the view. Okay, so the next we're gonna talk about this squeeze. Okay, so that's also some other useful function. Okay, so for a quick note, so squeeze is simply, that is something for us to reduce the dimension of size 1. Okay, so whenever we have some dimension that has exactly the size of 1, so that is pretty, sometimes it is useful, okay, but sometimes we do not need that, so we might just want to get rid of that. Okay, so that's the idea of this squeeze. Okay, so let's have a look. Okay, all right, so let's say again we're gonna use this A, so this will be some random number. Okay, so let's say we have a lot of dimensions. Okay, let's say we have 5 dimensions. Okay, so let's say we have 4 1 2 1 maybe. Okay, okay, so that should be a pretty large one. Okay, well, yeah, it is pretty large. Okay, but we know the meaning of this, right? Okay, good. So let's try to squeeze that. Okay, so we're gonna let this A to squeeze. Okay, all right, and let's try to see what is A there. Okay, maybe we should write this as torch, right? Torch.squeeze. Okay, good. So now it helps us to reduce or to simply remove all those dimensions with those ones, right? So now that'll be simply giving us this 4, 4, and 2, right? So let's have a look on the shape. Should be the shape of it, right? Or the without shape. Okay, good. So this gives us this 4, 4, 2, right? So that removes all of those ones, those dimensions with size of 1, right? Good. So, but what if we wanna, we wanna remove the certain dimension? Okay, so sometimes we wanna just keep this one, maybe for perhaps, right? And we wanna remove this one. Okay, so how do we do that? We can input something. Okay, so here, okay, let's have another example maybe. Okay, so we're gonna have this squeeze A, but we're gonna specify the dimension. Okay, so this is dimension 0. Okay, so this is not 1. This is dimension 0, and this is dimension 1, and this is 2. So we're gonna squeeze the dimension 2, but we're not gonna squeeze this. Okay, and that should be able to give to give us this 4 4 2 1. Okay, in this, let's see. Okay, so that's it, right? So that's how we do this squeeze for some certain dimension. Okay. All right, good. So, but what if, what if we accidentally maybe we put something else here? Okay, something that is not 1. Maybe let's say we want to try to squeeze this dimension. Okay, what will happen then? Let's see. So, for example, if you want to squeeze this dimension, so this 4, okay, so what will happen? Let's see. So there's nothing happen, right? So this is still 4 4 1 2 1, and nothing happened, right? So because this is not 1, so it doesn't squeeze. Okay, good. All right, very nice. So the next, the opposite of squeeze, right? So that would be the unsqueeze. Okay. So unsqueeze is simply to expand dimensions. Okay. All right, and that's pretty straightforward. Let's have a look. So again, let's say this A is some random number. Okay, so let's say 442. Okay. All right. So let's print shape. Okay. All right. So let's try to unsqueeze that. Okay. So then we simply need to specify where we want to unsqueeze that, right? So where we put that extra dimension. So let's say A is going to be the torch, unsqueeze. Okay. A. Okay, so the dimension is going to be, let's say, put this at dimension 1. So put it here, okay, between those two. Okay. All right, so that gives us this, right? And that simply, so with this one size 1 for some dimension, that is simply put some extra brackets, right? And that doesn't have any number, really some real elements. So that simply adds some trivial dimension to that, right? Okay, but sometimes it is useful, right? So be careful. Okay, good. All right. So the next, okay, so next we're gonna talk about this pad. Okay. So pad doesn't change the dimensions. Okay. So it only changes the let's say the size of dimensions. Okay, so you simply, so by padding we simply expand along the dimensions, right? So we don't change the number of dimensions, but we change the shape or the size of each dimensions or some dimensions. Okay, so we simply add some values or some coefficients or some parameters along some dimension, right? Okay, good. So the size or the value of the shape, or, right? So the size of dimensions. Okay, good. So, and there are a lot of different types of padding, right? So we can use constant or reflect or replicate, right? So we'll talk about those later, but today we're gonna simply use some constant, which is pretty easy. Okay, good. So all right, so we're gonna so this pad, that's something from the functional, okay, torch. and function. Okay, let's say this is called f. Okay, so we say that let's have this a. Okay, let's put some zeros, and with the shape of 2, 2, and 1 maybe. And let's have a look at this a. Okay, so those are with those dimensions, and those are zeros. Okay, good. So okay, and we can also print the shape. All right. Okay, so next we're gonna pad this. Okay, let's try the padding. So let's put this a as the f of pad. Okay, and a, and we're gonna put this parameter. Okay, pad. Let's say we have 2, 1, and 2. Okay, I'll explain this shortly. Okay, and we're gonna put this mode as constant, and we're gonna put the value to be 1. Okay, so this simply means that let's put a comment. So this means that, okay, so we're gonna always have, like, if you have two numbers here, okay, so for this pad, for this parameter, so this simply means that we're gonna pad one dimension with those value. We always have one value of 1 for all of those. Okay, so we're gonna put one dimension to the left, padding to the left, and gonna have 2 dimensions padding to the right. And which one we're gonna pad to? We're gonna pad those dimensions, okay, to the last dimension. Okay, so by what do you mean by the last dimension? Let's have a look on this result. Okay, so let's print this a. Okay, all right, so good. So now we can see that we have, okay, padded all of those ones. Okay, so on the last dimension, so that'll be the most inside one, right? So okay, let's put a comment here for the last, or the let's see, the most inside dimension, and pad one dimension to, let's say this is not one dimension, right? So one size maybe, yeah, right? So because this is not called dimension, right? So this is called a size, right? Because those are in the same dimension. Okay, so we can try to print the shape and have a look. Right? So okay. So this only changes the size or the shape of this dimension, right? So we still have 3 dimensions, but here we're gonna change this size 1 to size 4, right? With all of those padding. Okay, so pad 1 size to left and 2 to right. Okay, so 1 here, 2 here, 1 here, 2 here, 1 here, 2 here, 1, 2. Okay, so that's the meaning of this 1 and 2. Good. So you want to ask that, what if we want to, pad not only for the last dimension, we want to also pad for some second last dimension. How do we do that, right? So okay, so we simply put more numbers after this, Okay, so that would be noted as the second last dimension. Okay, so let's have a look on that example. Okay, good. So let's have this A again, the same as before. Okay, so we're gonna pad this A. Okay. So now let's put something else. Let's say we still have 1, 2 as before. Okay. And then we're gonna, for the second last dimension, we're gonna pad something else. Let's say we have 2 to the left and 1 for the right for the second last dimension. Okay. All right. And we're gonna have those again as the same as before. Okay. And print that. Okay. Good. So now let's have a look. What is this? So we can see that what are those things in the beginning? We have 4 zeros, right? Remember, well, we only have zeros in the beginning, so we have those two exactly the same as before, right? So we pad the last dimension with 1 and 2, 1 on the left, sorry, not that, 1 on the left, 2 on the right, 1 left, 2 on the right, 1 left to sorry, 1 left to right, 1 left to right, right? So that's for the last dimension, the most inside one, right? For the second last dimension, we're gonna count the other bracket, right? So that's with the inside of this bracket, we're gonna do something. So we're gonna pad 2, okay, to the left and 1 to the right. So we're gonna have those two pad to this, right? Because we have already done the padding for those two, so we're gonna pad the second last dimension. So this would be those two. So that's meaning this two, right? So this is 2. 2 is for those two. We're gonna pad 1, so that stands for this one. Okay, good. And also the same thing for this 2 and 1. Okay, so those are the meaning for this 2 and 1 for the second last dimension. Okay, so 1 to left, 2 to right for last dimension, and 2 to left, 1 to right for second last dimension. Okay, so this is what we did here. Good. So